Hey guys, so this next video is going to start our next unit of study, which is going to be over polynomials. And before you watch this video, you were supposed to copy down some definitions for the vocabulary terms in that first table in your 8.1 day 1 notes. So I'm going to go ahead and show you the definitions that I have now that you've copied those down. Yours may not be word for word exactly what I have, but they should be pretty close, and you should have some key phrases in there. So if you need to adjust anything, add anything, get rid of anything, feel free to do that. But I did want you to get a glimpse as to what these words meant before you watch this video. Okay, so here are the definitions that I have in mind. Again, you don't have to have it word for word, but it should be pretty close to what you found. So the first vocabulary term we have in this section is called a monomial. And what a monomial is, it's either a number, a variable, or the product of numbers and variables. And the key word there is product. Okay, so some examples of monomials. A monomial can be just a number itself. Okay, so for example, the number 12, we would consider that a monomial. You can consider a variable by itself just to be a monomial. So for instance, the variable y, that would be a monomial. It can also be the product of numbers and variables. So we could have a negative 5x squared y. That would be a monomial, okay, because this is all multiplication here. X squared means x times x, so that's an example of a monomial. You could also have a division problem like c over 3. Okay, because division is really multiplication in disguise. C over 3 means the same thing as 1/3 times c. So that's also an example of a monomial. So basically, the key to a monomial is it's any combination of numbers and variables as long as it's written as a product or a quotient. Okay, you just can't have sums or differences there. When you add a sum or a difference, plus and minus signs, that's when you get to what are called polynomials, which was the next term on your table here. A polynomial is either a monomial, or it's the more often than not we refer to it as this, the sum or difference of two or more monomials. So if I were to take one of these monomials and another one and put them together using a plus or minus sign, that would give me a polynomial. For instance, the variable y plus 12 makes these two separate monomials one polynomial. Okay, poly means more than one. If you ever talked about polytheism or polygons, okay, that's the prefix for more than one. Mono means one. Okay, so y plus 12 is an example of a polynomial. You could also have one larger than that. Let's say 3x squared minus 7x plus 2. That's another example of a polynomial. The degree of a polynomial, okay, that's the next term you had. The degree of a polynomial is the value of the largest exponent. Okay, value of the largest exponent. So if I had a polynomial that looked like this, let's say 7x minus 5x to the fourth plus 3x squared minus 8, okay, its degree is going to be 4. Okay, its degree is going to be 4 because its largest exponent is a 4. Okay, that x to the fourth right there. And then finally we have standard form of a polynomial. Standard form, all that means is that the exponents are written in decreasing order from left to right. So if I wanted to take this polynomial up here and I wanted to rewrite it in standard form, it would look like this. We would start with the largest exponent, okay, and the term that has the largest exponent is this negative 5x to the fourth. So this would be negative 5x to the fourth first. The next largest exponent is my x squared over here. So then I would take the term plus 3x squared. And then you remember from our last unit, okay, if there's a variable but no exponent written, that means it's an x to the first. So the next term would be plus 7x to the first, or just plus 7x. And then our last term would be this minus 8 here, which doesn't have a variable, so that would be our constant term. Okay, so that again is a look at some of those vocabulary words I'll be using this unit. Just make sure, again, your definitions somewhat match these right here, and that you have some examples. They don't have to be exactly like mine are, but that are pretty close to what I have. Okay, moving on to the next chart you have. In this section here today, most of what we're going to be doing is talking about how to classify polynomials. When we classify polynomials, we do that in two ways. We first classify them by degree, and then we classify them by the number of terms. So I'm just going to give you some examples and some more vocabulary here in this next table. First of all, we'll talk about the vocabulary terms we use for degrees. So degree, again, means the value of the largest exponent, and when we're talking about the exponents, we're referring to the exponents on the variables. So if you have the polynomial 6, well, 6 doesn't have a variable, okay? So we would say its degree is 0, okay? You could say that this is 6x to the 0, but we know from our exponents unit that x to the 0 is equal to 1, so that's why we just can leave it as 6, okay? So the degree of a number without a variable is always going to be 0, and we have a special name for that. We've used it many times before in this class. That is called the constant. Okay, anytime you have a polynomial degree 0, we would call that a constant polynomial. 5x plus 9, that's a polynomial, and its degree is 1, because the largest exponent on the variable there is an x. We have an x to the first is 1. Polynomials with degree 1, we refer to them as linear polynomials, another word we've used before. Every time we graphed linear equations, okay, those were always polynomial equations with largest exponent of 1. Okay, that's why we call them linear. When you have an x squared in your polynomial, for instance 4x squared plus 7x plus 3, that makes it a degree 2 polynomial, and we have a special name for those kind of polynomials. Those are called quadratic polynomials. And that's something we'll be studying here in the spring. We'll be talking about how to graph quadratic equations and solve quadratic equations, okay, in the spring. Big part of Algebra 1. Our next polynomial here is 2x to the third, or 2x cubed. Its degree is 3, and we call this a cubic polynomial. And then finally, once you get to 4 and up, it's not very exciting. Okay, so this right here, 8x to the fourth minus 2x cubed plus 3x, would be a degree 4 polynomial, and we just call this a fourth degree. And so if you had a polynomial with an x to the fifth, that one would be called a fifth degree, sixth degree, etc., etc. So beyond this point, you just say the number nth degree. Okay, but the ones you need to remember, the terms you need to remember, are constant, linear, quadratic, and cubic. Okay, that's only one way to classify polynomials. So we use the degree, but we also use the number of terms. So now we're going to go to the second column here, and we're going to talk about the vocabulary words we have for number of terms. So going back to our polynomial 6, okay, 6 itself is one term. Okay, there's no plus or minuses with the 6, it's just 6. And so we say it's one term, and the vocabulary word we use to describe a one-term polynomial is a monomial. We had that up in the very first table. Okay, again, a monomial can be just a number, a variable, or the product of numbers and variables. So if you don't see any addition or subtraction signs, you know you have one term, and it's called a monomial. 5x plus 9, well, I see this plus sign right here, and that plus sign separates my two terms in this one. My first term is 5x, my second term is 9, so this is a two-term polynomial. We have a special name for two-term polynomials. Those we call binomials. The prefix bi means two. Like bicycle. Bicycles have two wheels. The next polynomial, 4x squared plus 7x plus 3, has three separate terms. Those we call trinomials. Just like a tricycle has three wheels, or a triangle has three sides. 2x cubed, even though its degree is 3, it has only one term because there's no addition or subtraction signs there. Okay, so that is a monomial. And then 8x to the fourth minus 2x cubed plus 3x, that has three terms, and again that one is a trinomial. Anything beyond three terms, kind of the same way we do the fourth degree right here. Okay, so if you have 4 or more terms, again it's not very exciting, it's just polynomial with that many terms. So for instance, if you had 4 terms, it'd be a polynomial with 4 terms. There's really no special name for it. Okay, so just moving on to those few examples you have on the bottom. we're going to classify these polynomials, okay? But before we do that, we're going to write them in standard form, okay? So two parts to each of these examples. Number one is we're going to write each one in standard form, meaning we're going to start with the largest exponent and work our way down. And then second, we're going to classify it by degree and number of terms. So for number one, I have 3x plus 4x cubed. To write this in standard form, I need to start with the term that has the largest exponent, and that would be my 4x cubed. So that is going to come first, and then my second term is going to be this plus 3x here. So this is the polynomial in standard form, 4x cubed plus 3x. Now I'm going to classify this first by degree. It is a cubic polynomial because it has a exponent of 3 as its largest exponent, so we call this a cubic. There are two terms, so we refer to this as a binomial. So 4x cubed plus 3x is classified as a cubic binomial. Number two, we have 4x minus 1 plus 5x squared plus 7x. To put this in standard form, I'm going to start with the largest exponent I see, a 5x squared. Okay, the next largest exponent I see is my 4x to the first, so I'll put that next. I also, though, have a 7x to the first, and it really doesn't matter what order those go in. You'll see why in a moment. Okay, so I've used my 5x squared, my 4x, my 7x, and now I just have this minus 1 that goes at the end. 4x and 7x, the reason it doesn't matter which goes first and which goes second is because these are actually like terms, and we know that to simplify expressions, we always combine like terms. So I can combine 4x and 7x to get 11x, which is why it didn't matter which one came first. So this polynomial in standard form is actually 5x squared plus 11x minus 1. This is a degree 2 polynomial, so we would call this a quadratic, and it has 3 terms, so we refer to this as a quadratic trinomial. Finally, we have 5x to the fourth minus 3x minus 4x to the fourth minus x to the fourth. Okay, so I'm going to, again, put my polynomial in standard form from highest exponent to lowest exponent first. I have a few x to the fourths here, so I'll just start with the first one, 5x to the fourth. That's the highest exponent I see. Then I have a minus 4x to the fourth over here, and then a minus x to the fourth over here. And then finally, the only term I have left is a minus 3x. Well, when you combine your like terms here, 5x to the fourth minus 4x to the fourth minus x to the fourth, you get 0x to the fourth minus 3x. And really, 0x to the fourth is unnecessary to write. There are no more x to the fourths, so we could say this polynomial just becomes negative 3x. And so, to classify this polynomial here, its degree, there's an exponent of 1 on that x right there, so we call this a linear polynomial. It's only one term, so we refer to this as a linear monomial. Okay, as always, if you have any questions on this video, feel free to jot those down. You can also email me your questions so that I can address those the next time I see you. And anything you didn't understand in this video, anything you want to go back over, feel free to rewind and rewatch that. And until I see you the next time, have a nice day. You're all wonderful people. Take care.